Dr. T. Kusuma, Assistant Professor, Department of Mathematics, VNR VJT. Today I am going to deal very important topics, Fourier series for even and odd functions. So first I will introduce what is even function, odd function and related properties. So first I define the even function. A function f of x is said to be even function f of minus x is equal to f of x for all x. This condition is satisfied. The function f of minus x is equal to f of x, then the function is called even function. Suppose I take f of x is equal to x square. So replace x by minus x, then minus x whole square is also x square. Minus x whole square is equal to x square. That is equal to f of x. F of minus x is equal to f of x, then function is called as even function. So this condition is satisfied, the function is called as even function. Now example is x square is the even function, cos x is the even function, secant x is the even function, because cos of minus x is equal to cos x, the function is called as even function. Secant of minus x is equal to secant x, then the function is even function. That means f of minus x is equal to f of x, then the function is called as even function. Now the properties of even function. The first property, the product of two even functions is again even function. I consider the first function is even function, and second x square is the even function, and second one is the cos x is even function. This product is also, the x square cos x is also even function. And second condition, sum of two even functions, again even function, x square plus cos x. X square is even function and cos x is even function. The sum of these two functions is also even function. The property number 2. And 3. The graphical representation of even function is symmetric about y-axis. Suppose I consider the function x square. So represent in the x-axis, y-axis, x-axis, y-axis, and the y is equal to x square is, you know, that parabola. So the parabola graphical representation is it is y is equal to symmetric about y-axis. This is the curve. So when your function is symmetric, your function is even function, it is a symmetric about y-axis. And third one, the function is even function, the integral value of minus a to a f of x dx value, it is equal to 2 times of 0 to a f of x dx. In 2 times of 0 to a, sir. The function is even function, satisfy these 4 properties. The first property is product of two even function is equal to even function, and sum of even function is equal to even function, and third property is the graphical representation of even function is symmetric about y-axis, and fourth one is the integral value from minus a to a f of x dx is equal to 2 times of integral 0 to a f of x dx. Let us discuss about the odd function. A function f of x is said to be odd function if f of minus x value is equal to minus times of f of x. This condition is satisfied. F of x is equal to f of minus x is equal to minus times of f of x, then the function is called odd function. So x cube is the odd function, and sin x is the odd function, cos x is even function, secant x even function, cosecant x odd function. So now it is replaced. Suppose I take f of x is equal to x cube, I replace x by minus x whole cube. This value is equal to minus times of x cube minus f of x. F of minus x is equal to minus f of x, then the function is called as odd function. So the properties of odd functions. The first property, product of two odd functions. Product of two odd functions. The first function is odd function. X is the odd function, and sin x is the odd function. Product of these two odd function is even function. So x, replace x by minus x here. Sin of minus x, so it is equal to minus x. This I take the f of x. I replace this value is f of minus x. So minus x sin of x minus sin n x So that is equal to x sine x. So f of minus x, it becomes to f of x. Then the function it is called as even function. So remember, a product of two odd function is even function. Sum of two odd function, take the two odd functions. Again I consider x is the one odd function, sin x is the another odd function, and this is considered as some g of x. So check whether it is odd function or not. G of, replace x by minus x minus sin x. So this can be written as minus times of x plus sin x. Minus times of x plus sin x is equal to minus g of x. G of minus x is equal to minus g of x. So sum of two odd function is odd function. So again odd function. And graphical representation of odd function is symmetric about the origin. Suppose I take x-axis here, x-axis and y-axis, and the graphical representation of y is equal to x line. This is the y is equal to x line. So this is the odd function. So you observe that it is a symmetric about origin. So it is the lies in the opposite of first octant, first coordinate and third coordinate. This is a symmetric about origin. And fourth one, if the function is odd function, integral minus a to a f of x dx value is equal to 0. If the function is odd function, integral minus a to a f of x is equal to. So if the function is odd function, satisfy the condition f of minus x is equal to minus f of x. And some properties, some product of two odd function is equal to even function. Sum of odd function is equal to odd function. The graphical representation of odd function is symmetric about the origin, and integral value of minus a to a f of x dx is equal to 0. Then go for a Fourier series for even an odd function. So suppose let us consider the function f of x in the interval minus pi to pi. Remember the interval is here considered minus pi to pi. You know the formula for Fourier series function for f of x in the interval minus pi to pi. F of x is equal to a naught by 2 plus summation n is equal to 1 to infinity a n cos nx plus summation n is equal to 1 to infinity bn sin nx, where a naught is equal to 1 by pi times of integral minus pi to pi f of x dx, and an is equal to 1 by pi times of integral minus pi to pi f of x cos nx dx, and bn is equal to 1 by pi times of minus pi to pi of f of x sin nx. This is the basic Fourier series expansion formulas I already explained in the previous lecture. Now case number 1. Suppose my function, this function f of x is even function. Then what happened? Above formula. So the function is even function. Let us see the value of a naught. A naught is equal to 1 by pi times of integral minus pi to pi f of x is equal to even function. Then this integral value, already I told in the properties, 2 by pi times of integral 0 to pi f of x dx. The function is even function. And now coming to the an value, an is equal to 1 by pi times of integral minus pi to pi f of x cos nx dx. So your given function is even function. This is the even function, and cos nx, e means even function. So this is even function, this is even function. The product of these two functions is again even function. Thus this is integrand is even function. Then you can write 2 by pi times of integral 0 to pi f of x cos nx dx. Now let us go for bn value. Bn is equal to 1 by pi times of integral minus pi to pi f of x sin nx dx. So f of x is even function. Sin nx is odd function. So the product of even and odd function, the product of even function and odd function, it is equal to the odd function. So this is the odd function. The complete integrand, this integrand is odd function. So what is the odd function integral value? Bn is equal to 0. So if the function is even function, the Bn value is 0. Bn value. A naught value is 2 by pi times of integral 0 to pi f of x. An value is 2 by pi times of integral 0 to pi f of x cos nx dx. Now let us just conclude formula. F of x is equal to a dot by 2 summation n is equal to 1 to infinity an cos nx summation n is equal to 1 to infinity bn sin nx. A naught is equal to, if the function is even function, what is the bn value? 0. What is the a naught value? 2 by pi times of integral 0 to pi f of x dx. An is equal to 2 by pi times of integral 0 to pi f of x cos nx dx. 2 by pi times of integral 0 to pi f of x cos nx. So the finally you observe that f of x, this sin nx term is vanished when the your function is even function. When the your function is even function, then you get only two terms a naught by 2 and n. So this series is called as Fourier series even function. So the Fourier series of even function contain only cosine terms. So Fourier cosine series formula is f of x is equal to a naught by 2 summation n is equal to 1 to infinity an cos nx, and where a naught is equal to 2 by pi times of integral 0 to pi f of x dx. An is equal to 2 by pi times of integral 0 to pi f of x cos nx dx. So the function is even function, that is also called as Fourier cosine series. Let us go for next one.
చెప్పండి మేడం.
క్లిక్కింగ్ అవ్వలేదు సార్, ఇప్పుడు అయింది సార్.
ఏమైంది మేడం?
ఆగిపోయింది సార్, ఒకసారి స్టక్ అయింది సిస్టమ్.
సెట్ అయిపోయింది మళ్ళీ ఇప్పుడు?
సెట్ అయిపోయింది సార్. కంటిన్యూ చేయనా సార్? Now Fourier series for odd function. So if the function f of x is odd function, it contains only sine terms. It is called Fourier sine series. So my function is odd function. F of x is odd function. Then what happened? So here integral a naught value 1 by pi into integral minus pi to pi f of x dx. The a naught value, what is the a naught value here? F of x is here odd function. Odd function, if it is odd function, the integral value is 0, a naught 0. Coming to the an is equal to 1 by pi times of integral minus pi to pi f of x cos nx dx. F of x cos nx dx. F of x is odd function. Cos nx is even function. Odd function into even function is odd function. So odd function into even function is odd function. So this integral value, an value is also 0. Now coming to the bn. Bn is equal to 1 by pi times of integral minus pi to pi f of x sin nx dx. F of x is odd function. Sin nx is odd function. Odd function into odd function, again odd function. Product of odd functions are odd function. Sorry, even function here. Odd function into odd function is even function. So then bn value is equal to 2 by pi times of 0 to pi f of x sin nx dx. So in this case, if the function is odd function, the series is called Fourier sine series. So then a naught value is 0, an value is 0, bn 1. Your sine series, only remaining term is sine term. A naught 0 and an 0, you get only bn term. Now let us go for one example, and before going to the example procedure, So first identify your function, even or odd function in the given interval. And after that, if it is odd function or even function, so the first case is even function, just calculate a naught an because bn value 0. And the function is odd function, calculate only bn value since a naught and an values are zeros. So let us go for example. So here one problem I consider based on the interval minus pi to pi. F of x is equal to pi square by 12 minus x square by 4 in the Fourier series in the interval. So first in the interval I will check this function is even or odd function. So basically I go for x replaced by minus x. Let us start a solution of this question. X by minus x, pi square by 12 minus x place low minus x replace x square by 4 again. So when replace x by minus x, again you get the same function. This function is called as even function. So see graphically. So the graphical representation of f of x is equal to pi square by 12 minus x square by 4 is the graphical. You observe that this function is symmetric about y-axis. Symmetric about y-axis. Symmetric about y-axis. So then this function is called as even function. If the function is even function, clearly you know that the function is even function, you calculate a naught value and an value. So first to find a naught. To find a naught, how to calculate a naught? A naught is equal to 2 by pi times of integral 0 to pi f of x dx. This is the formula for a naught. So now 2 by pi times of integral 0 to pi f of x value pi square by 12 minus x square by 4 dx. Start the integration. 2 square by pi integral pi square by 12 integral 0 to pi square by 12, it is a constant, 1 with respect to x minus 1 by 4 times of x square integration x cube by 3, the limits varies from 0 to pi. Substitute the limits. 2 by pi times of upper limit pi into pi square pi cube by 12 minus with the place x pi cube by 12 upper limit minus lower limit is 0 minus 0. So pi square by 12 pi square by 12 minus pi square by 12 is also 0. 0 times of anything is 0. So in this case you got the value of a naught is 0. Now let us go for to find an. To find an. So for that an is equal to formula 2 by pi times of integral 0 to pi f of x cos nx dx. 2 by pi. 2 by pi times of given function 0 to pi. What is f of x? See, f of x is equal to pi square by 12. F of x is equal to pi square by 12 minus x square by 4 times of cos nx dx. Now start the integration. So apply the integral by parts of these two functions. It's pi square by 12 minus x square by 4. We can take u. Cos nx is v. So already I told the formula integral uv dx is equal to u into v1. What is the v1? Integration of v minus u dash power. It is means differentiation of u v2 plus u2 v3 so on. Use this formula. So now 2 by pi times of the first function is u pi square by 12 minus x square by 4 u into v1. v1 is the integration. Integration of cos nx is, what is the integration of cos nx? sine nx by n minus differentiation of u. This is the u. U differentiation is pi square by 12 is 0 minus x square differentiation is 2x by 4 and v1 integration is called as v2. So sin x integration is minus cos nx by n is the v2 plus u2. u2 means in differentiation of this u1 minus it is a 2 by 2, so it is a plus here minus x by 2 integration differentiation is 1 by 2, x differentiation is 1 by 2 my of, so v3 means integration of v2 minus cos nx integration is sin nx by here n square by nn here n cube sin nx by n cube plus differentiation of this term is 0, then you stop here. The limits varies from 0 to 5. Remember, after you, whenever your differentiation is term is, the first term is constant, then you stop this integral by parts formula. So first replace pi in the place of x. The first 2 by pi times of, so pi square by 12 minus pi square by 4 sine n pi by n minus of minus plus pi by 2 minus of cos n pi by n square, so plus minus 1 by 2 minus sine pi by n cube bracket. This term are upper limits. These three terms are upper limit minus lower limit. You know sine 0 is 0. No need to write all. 0 into anything is 0. And coming to this here, minus into minus plus, plus into minus, minus the complete. X value is 0. 0 into anything is, this term is also 0. And sine 0 term is 0. So the lower limit or 0. Now coming to the upper limit part, 2 by pi times of sine n pi. What is the value of sine n pi? 0. Sine n pi value is 0. The first term is 0. Plus into minus, here minus pi by 2 n square cos n pi. What is the value of cos n pi? Minus 1 whole power n. Cos n pi value is minus 1 whole power n. And sin pi also 0. Sin pi also 0. This term, third term is also 0. So here after simplification 2 by pi minus pi by 2n square minus 1 whole power n. This pi cancel, this 2 cancel. You finally get the an value is equal to, an is equal to minus 1 power 1. Bases are equal, you should be add the powers also. You can minus 1 whole power n plus 1 by n square is the an value. An is equal to minus 1 whole power n square, minus 1 whole power n plus 1 by n square. Now finally write the Fourier series expansion of your function. So your function is, what is function? F of x is equal to, what is the Fourier? A naught by 2 plus summation n is equal to 1 to infinity an cos nx. What is the bn value? 0. Why? So your function is even function. If the function is even function, bn value is 0. So f of x is equal to pi square by 12 minus x square by 4, your function. A naught, in this case a naught value is 0 plus summation n is equal to 1 to infinity an. What is a minus 1 whole power n plus 1 by n square cos nx. Now this is called Fourier cosine series. Only cosine terms are there. So expand pi square by 12 minus x square by 4, n is equal to 1. Put the n is equal to 1. Then minus 1 whole square by 1 square cos 1x. N is equal to 2 case minus 1 whole cube by 1. It is a 2 case 2 square cos 2x. N is equal to 1 after the 2, after the 3, it is minus 1 whole power 4 by it is the 3 square cos 3x, so on. Finally, you get the your function pi square by 12 minus x square by 4 in the expansion of Fourier series cos x minus cos 2x by 2 square plus cos 3x by 3 square, so on. This is called as Fourier cosine series. Now, here I explained your function is even function, then the bn value 0, then your function is expressed as cosine series terms. So, let us practice these questions similar manner. Here function is odd function, then the case a not 0 and an as well as 0. In this function, x is odd function and sin x is odd function. The first one is odd function, second, the product of functions are even function. So, in this case, bn value 0. So, let us solve these two questions for make it easy your problems. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.